Greetings, pre-calc students. This video goes through a trig graph. It's a little more challenging than the ones we've done lately in class. Okay, so just want to pay attention to see, first of all, what order I go through when I'm compiling this graph, and also, of course, the different characteristics that might have been changed from the parent function. All right, so here's the equation. I don't know if you guys can see it okay, but it's y equals -2 minus sine 6 times the quantity theta plus 18 degrees, all right? So the middle line, of course, as you guys know, the middle line or the axis is going to be -2. The amplitude is 1, all right? The negative just means, well, it's going to be a negative sine curve, but the amplitude is always measured as a positive number. So the amplitude is 1. The b value here, the number of cycles the graph makes in 360 is 6, which means the period, the length of one cycle, would be 60 degrees. Right? The period is 360 divided by this number. So the period is 60 degrees. And the phase shift is 18 degrees to the left, so -18 degrees. All right? So this is all kind of done for you. I would not give that to you, of course, on a test. It's just I kind of saved some time and wrote all these out first. And now the idea is we want to compile a decent graph. So how do we do that, and what is expected of you? I'll go through in this video. All right. I had to do the Run the Bulldogs bobblehead as a good luck. This is my third take for this video, so yeah, it's been a rough one. All right, so first thing we ought to do probably is to compile the theta axis, all right, so the horizontal. All right, so the horizontal is going to be affected by the phase shift and the period. Together they will allow us to mark up the theta axis, okay? Then to mark up the y, or f of theta axis, we will use the middle line and the amplitude, right? The axis and the amplitude. So these two together will allow us to mark up the y-axis, these two together on the x-axis, okay? Phase shift is -18 degrees, so that's where the starting value is going to be on the theta axis. The period is 60 degrees, so from here we want to add 60 to find the last point we'll be plotting. -18 plus 60 is 42. So 2 of our critical points will fall at those endpoints, all right? For the other 3 critical points we've got to plot, my recommendation is to just cut these in half, find the middle number, or find the average, all right? Or if with the knowledge that the period is 60, then just add 30, right? Add 30 to -18, and you could figure out that middle number. Right? Or alternatively, just find the average, add them up and divide by 2. And you get 12, all right? And then, because we added 30 to get here, if we just add 15, we'll get that middle number, which is going to be -3 degrees. And if we add 15 here, we'll get 27 degrees for that other theta value for our critical points. So here we'll have 5 theta values of our critical points already written down, all right? Now, the middle line is -2, and the amplitude is 1, right? So the middle line is going to be -2, and then we'll go up 1 and down 1 from there to rope in our y values, all right? Now here is where I kind of like allow you guys to sort of cheat a little bit. The theta axis that you drew, I am totally fine if you want to let that be the middle line, all right? So if you want to let this line actually be the line f of theta, or y equals -2, we can jot down a -2 there, instead of having to call it 0 and then going down from there. I'd almost rather you do that, but these problems do get kind of tedious sometimes, so I do let you call essentially the theta axis. You don't have to mark that up. You can mark up the -2 axis instead. From there, we're going to go up 1 and down 1. Before we do that, let's draw our y-axis. So this is -3. The y-axis will be right about there, right, where you have 0. Let me extend it. Well, it's probably fine. All right? So here's our f of theta axis. Here's our theta axis, or actually our -2 axis. We're going to go up 1 from here and down 1 from here. And I do recommend drawing a dashed line where we've gone up 1 and a dashed line where we've gone down 1. Try to be consistent, equidistant from the axis, because the axis is the middle line after all. It's a little bit slanty, but not bad. So this kind of shows you where our graph is going to be drawn, right? It's not going to go anywhere to the left of negative 18. It's not going to go anywhere to the right of 42. It's not going to go below negative 3 or above negative 1, right? So the true theta axis is actually up here at 0, right? But you don't have to worry about that. All right, as I said, we can kind of cheat and just call the axis that we labeled the middle line. All right, now all you got to do is plot the 5 critical points and then connect the dots, all right? And that's going to depend on what kind of a function we have. So we have a negative sine curve, right? Negative sine curve. So if the positive sine curve looks like this, right? It starts at the middle, then hits a maximum and goes to the middle. Oh, it looks like that. That's the positive sine curve, right? So the negative sine curve, you really just want to memorize what these shapes look like, but the negative sine curve also starts in the middle, but it goes down first instead of up first, and then ends up going like this. So it's a negative sine curve. I don't really need the positive sine curve. So that's the shape we're going to draw. So we want to have, at the point negative 18, negative 2, right? At that point, we'll want to draw a point, because it's a negative sine curve. It starts on the middle, on the function's axis. Then it's going to go down. So here, where x is negative 3, we'll have a point down there at negative 3. That's coincidental. Then you're not going to have a point on the y-axis. It's just really there as a reference, all right? The next point's going to fall here, back at the middle line. You're only putting points at the 5 critical values. All right, then you'll reach a maximum, and then you'll hit back to the minimum, or back to the middle, all right? So our curve now, finally we connect the dots to that sine curve. We know what it looks like, and we have our graph, okay? You don't need to draw these dashed lines here. I just do recommend it so it's kind of, it's clear where the range of the graph is, right? Negative 3 to negative 1 would be the range of the function. If I asked you for the range of this function, that's what it would be, right? Negative 3 to negative 1, all right? The domain is all real numbers, all right? But we were only drawing one cycle. So the domain of that one cycle would be negative 18 to 42, all right? But that's not as important, all right? So just kind of wanted to go over this stuff with you guys. I hope this is a little bit of a challenging problem, right? A lot of stuff going on. I didn't change everything, right? I didn't change the amplitude. The amplitude here is 1, same as the parent function. So if that was changed, if say the amplitude was 5, right? Then instead of going from negative 2 up 1 and down 1, we would have gone up 5 and down 5. So that would have just changed the range to negative 7 up to 3 instead of negative 3 to negative 1. All right? Anyway, I hope it's made some sense, and I will talk to you soon.